let's talk about the code that we've got so far for the Derby. Here's the driver program, and the driver program has got this idea that we've got a Derby object that's taking care of most of the work for us. We called the Derby object registration to mirror the idea that it's a registration desk. And the first thing that people do when they come in for the Derby is they just register, sign up for it, get their name in the pot. And we said for us that means that somehow they're going to supply us with a bucket, and we're going to use the bucket to hold on to all of the fish. Okay. Sooner or later, after everybody's registered, they come along and they've caught a fish, and so when they catch a fish, they supply us with the fish in hand, and they also hand over a bucket, second bucket, that looks like the one that's already hidden behind the registration desk. And so that allows us to take the sample bucket that they've supplied us with their first name and last name on it and go through the list of other buckets that are behind the registration desk and see whether or not we can find a match. Okay? That's as far as we've gotten there. Starting from the other end, a fish has just got a weight and a type, so nothing exciting there yet. Buckets have a first name and a last name, and we're using the list to store all of the fish. And so just a standard constructor in at that point, and the only sneaky thing that we've done is someplace when somebody comes along to the bucket and says it's time to add a fish, we're just going to use the list to hold on to the fish. In the Derby class, the Derby's got a name and it's got a list of buckets. And so there's one bucket for each of the fisher people. And the same deal there, when somebody comes along and register, we'll just get the list to hold on to the bucket for us. The tricky part starts to arrive when somebody comes along and says, oh, okay, I'm going to present you with the fish I've caught at the registration desk, and here's the bucket that looks like the one that you're trying to find. And that's the point where we break out our search feature. So index of is search for something, and we're going to go try to find a bucket that matches the one that they supplied. So index of is going to return whatever bucket matches, and for now we're just going to not worry about errors and presume that it always matches. There's always the correct person on the list. So we're just going to retrieve the bucket from whatever position it's in and then dump the fish into that bucket. Okay? And so the real bucket is the one that's hidden behind the registration desk that holds on to the actual fish. Throw away the bucket that they supplied us, and we'll wait until next time, and they'll have to supply us another sample bucket. So far, so good. What does index of need in order to do its work? So this needs equals for what type of thing? So looks like is a bucket object. And so we need to match one bucket against another bucket, which means in order for equals to do its job, we'd better supply it with, or sorry, for index of to do its job, we'd better supply an equals method. So here's public Boolean equals in the bucket class. Equals is the one that takes another object, and we'll insist that that must be a bucket object. There's the standard way that we write equals, and then we have to decide what makes buckets match. So when would I think the two buckets were the same? First and last name have to match. So if the last name doesn't match the other guy's last name, then it's definitely not a match. And the same thing for first name. Otherwise, I guess it must be a match, so we'll return true. That's the regular case. Okay, so the rule there is really simple. whenever you write index of, you want to go back and look at that object, whatever it is, and make sure that it's got an equals in order to do the matching properly. So the buckets are going to match, and so now we can dump the thing onto the list. Got it. Back to the driver program. We managed to add a fish for Fred. We'll give Fred another fish. Maybe a 30-pound salmon. And just to avoid any errors, I'm going to make sure that all of the other participants also have fish. So I'm going to make sure that Wilma gets a few fish. And she can have, what do we got here? A little small trout and an even bigger salmon. Try to mix them up a little bit. And we'll do one more to make sure that Barney's also got some stuff. So I'm purposely manipulating the test data so that every one of these people has at least one fish. Okay. So we did the registration, we did the adding of the fish. Now what's going to happen after the horn sounds? Derby's ended. Got to find the biggest fish. So that must be get biggest fish, or we'll call it get winner. So we'll talk to the registration people and we'll say, please find me a winner. What are they going to give us back? The bucket or the winning fisher person. We'll do something like that. Because if we can get the bucket back, that gives us the name, first name, last name on the bucket, and we can dig into the bucket and have them retrieve the biggest fish for us. Okay? So very likely afterwards we're going to say fish biggest is winner dot get biggest fish. And then print out both the first name and last name of the winner along with all of the information about that winning prize fish. Okay, so it looks like we're missing get biggest fish in winner, and we're missing get biggest fish in bucket, and we're missing get winner in registration. Which one do you want to write first? Get biggest fish. Write the smaller one. Why don't we go and write the one in the bucket since it's slightly smaller. Okay, so we've got buckets get biggest fish. So there's get biggest fish has to send back a fish. What's holding on to the fish right now? What variable? All fish has got the list of them, so we're going to have to talk to all fish one way or another. How are you going to retrieve the biggest of all of the fish?
Sorting.
Easier than sorting. Only want one of, so collections.max will do the work. So we can say collections.max of all of the fish that are on the list. And what you're given back is the fish, and at that point you can send the fish back as the winner. Doesn't understand collections, so we'll do the import statement. That that solves the collections problem. Now, it's still complaining. So out of all of that gobbledygook, there's that very second last word that says comparable. So that's that indicator that you got to have a compare to so that sort knows what you're sorting by. So the compare to belongs in what thing? Fish, because fish is the thing that are on the list. So we'll wander into the fish class and we'll write compare to. And compare to is given some other fish to talk to. How are we going to decide bigger for fish? By weight. So that's, just do the simple thing here. This is my weight minus your weight. Okay, so you can put it in a variable if you want. Just to be a little clearer maybe. And then we're just going to return the difference. Okay? So notice one of the advantages here is that we've isolated what biggest means for fish into just one function. So sometime later we could come along and we could make compare to smarter. Since we're keeping the type of fish, we could add some extra logic in the compare to that says, okay, well, if it's this type of fish, like a minnow, right? Any minnow that's over 8 ounces is probably bigger than, you know, relatively speaking, it's as big as it's going to grow as compared to a huge tuna. Right? So the fish can get smart as they want, make a little table of what kinds of fish grow biggest, etc. Okay? Or they could factor in length. If we added something into fish that kept track of their length, you could do it not only on the basis of their weight, but also how long they were. Okay? So lots of opportunity there. For now, that will work. Okay, so we've got compare to inside fish. And now when you go back to bucket class, it's still complaining. So the other trick here is that it's not enough for compare to just write it. You have to announce that it's available by saying implements comparable for fish at the top, which basically says, hey, there's a usable compare to inside. You can use this thing for sorting. And now if we save that and go back and look at bucket, now it's happy about collections.max. Okay, so there's biggest fish done. Okay, so back to the driver, we've taken care of that one. What about get winner? That belongs in the registration object, which is a bucket. So bucket needs a get winner. And get winner is going to give back a bucket. So how do you find the winner of the whole derby?
Do a collections.max is there compared to use collections.max and get biggest fish?
So get winner, if you translate it, is really saying get me the biggest fisher person or get me the biggest bucket. So we can still say collections.max of all of the buckets. Oops, what class am I in here? I'm in the wrong class. I'm looking at this going, no wonder that's not right. Hold it just a second here. Buckets give back fish. Yeah, wrong class. Let's go back and try this again. Go over to Derby. And I'm talking to the registration class here, and registration is in the Derby class. So Derby is the thing that needs get winner. And we'll do collections.max of, same deal, all of the fishermen, which is all of the buckets. And we can just send that thing back as the winner. Biggest bucket is the winner. Oh look, same problem there. Collections.max is saying can't do that because there's nothing inside the bucket class that says that they can be sorted in any way. Oh, okay. If we need to sort things inside the bucket class, I guess we'll do it the other way around. We'll make our promise first up here, which says it needs to be comparable for buckets. And as soon as you say that, it now complains and says, you didn't write it, so if you want, you can get Eclipse to write an empty compare to for you. I'm just going to change the name of that to something else. Okay, so this is bucket comparing itself to another bucket. So how are two fisher people going to compare each other? Standing side by side, say to one of them, hey you, which one of you two is bigger, you or fisher person B? So what does A do? Get my biggest fish. And conveniently enough, we can just reuse our get biggest fish thing. So that's my biggest fish. The other guy's biggest fish. Your biggest fish is talk to the other guy. That wasn't such a good name. Okay, so now fisherman A is holding on to his biggest fish. He's holding on to the other guy's biggest fish. What should he do now? The good part again. Let the fish talk to each other. So there's using fishes compare to compare one fish against the other. Okay, so the fish are doing the work of figuring out what makes a biggest fish, and all that we have to do is just send back the difference. So literally one fish talks to the other fish, figures out which one is bigger, and sends back a number that says I'm bigger or smaller. Oh look, that makes the Derby class okay. Let's go back to the driver. Let's do a print statement. Print out who the winner is. And we'll add one more line in here to print out the fish. Biggest type plus biggest dot get the weight. Okay, quick check. Who should it print out? Barney with the 67-pound trout, rather large trout. Run it, see what happens. Died.
I think your Wilma bucket didn't have the evidence.
Let's look at why it died out of interest's sake here. This says index out of bounds exception, which means there's that -1. The -1, when we tried add fish, we tried to retrieve something in add fish, we tried to get the -1 position, which caused the failure. Okay, and so if we go look at the last thing that we recognize here, which is our Derby driver main called add fish, this is the scene of the crime. Okay, and what it's saying there is -1 came in for the position variable, which means it didn't find somebody who we expected to be on the list. Okay, so we didn't check for errors and we got caught by not checking for errors, but that's okay. So why wouldn't we find somebody?
Equals.
Well, equals, or other option is a spelling mistake. Notice this says WEMA. Okay, so it wouldn't, sometime later when I put her in as WEMA, but then I was actually spelling correctly with Wilma, so Wilma and WEMA don't match, and so it wasn't finding her on the list. Would be my first guess, so we'll fix the little spelling mistake. So it's not always the code in this case, it happened to be the data that was sort of cruddy, and we'll run it again, and there's Barney Rubble with his 67-pound trout. Now it could be that it just picked the last one, so just for fun, I'm going to change that to a 7-pound trout. Who should win now?
Wilma.
Biggest one is Wilma with the 35-pound salmon, so we'll run it again, and there's Wilma with the 35-pound salmon. Oh, we're not quite done yet. But notice that we've already got, fairly quickly, a working application that will go and hold on to fish and find the biggest fisher person. You could put a GUI on the front end of this thing to have a button that says add fish, right, or register with a first name and a last name, drag those in so that you could, when they click the button, it would make the new people to add to the list. You could add another section to the GUI where they come after and they say add a fish, so they give their first name, their last name, kind of fish that they've caught, probably from a pick list, turn around and add their fish, right? So we're just missing the GUI front end on this thing so far. Okay, so let's continue on a bit here. We printed out the winner. What's the next thing that people are going to want to see? Not only the winner, but everybody's going to start to complain because they don't believe that Wilma could actually possibly catch the biggest fish. So they're going to want to see a list of all of the, you know, the fish that were caught, the biggest fish for everybody, so that they can see how they, you know, where they fit. Make sure there weren't any bigger ones. So we need to print out a list of all of the people in the competition in order by biggest fish. Well, at some point, we're gonna have to sort them, right? So, what should the main program do? What would be the simplest thing that you would like to be able to do in the main program? In terms of going through all of them? Even simpler than an iterator. A for each would be nice. So what I'd like to be able to say is go through all of the fishermen in the Derby. So that's go through all of the buckets in the Derby, which is being really the registration desk or behind the registration desk. Assuming I spelled registration correctly. And I'd like to print them out almost exactly the same as this thing. I'll change that to try to get them across one line. So instead of winner, we'd like to print out a bucket and I'll just put a print statement in here just to make it look a little pretty. And this is contestants by largest fish is what we're really trying to print out. Okay, so that's basically what we'd like to do. Sorry, that's I need my a fish variable here, don't I? So something like that. Go through each person that's been registered, each bucket that's been registered, print out their name. So just get rid of that. Their first name and last name along with whoever their biggest fish was. So that should be a bucket. Something like that. But we got this problem here that it says for each won't work on that registration object because, well, there's an array underneath. The registration thing is keeping an array of things. There's no iterator. So notice there's that word iterable tacked onto the end. And so it's saying there's no iterator in this class, so you can't run a for each on it because we know that for each uses an iterator to do the work. So the problem is that the registration class, which is the Derby object, is missing an iterator. Or to put it another way, if you want to run a for each on anything, it has to say implements iterable at the top for the type of things that you're storing, which in this case is buckets. Okay. And we'll add in the missing method that for each needs in order to make that work, and it's added in this empty iterator method. And that's the go get me an iterator and give it back to me as an iterator type of person. Okay, so this is really get iterator. So how do we make an iterator? It's a trick question. Well, but where's the iterator going to come from to start with? We'd rather not manufacture one ourselves. Anybody that will give us one? So the trick here is that all buckets, if you type its name, is an array list, and all buckets already has the ability to give us one of those iterator things. So we don't have to make one, we just have to go get one from the guy who makes them. Okay, so ArrayList already knows how to make iterators, so we'll just go grab one from ArrayList. And if you want, you can put that into an iterator object. It looks like this, iterator for bucket. So we can ask it for an iterator. Save it, maybe I can see if I can make that error message go away. What have I got? No variable. And then we'd be able to send that thing back. Okay, so if we do that and save it and get all the errors out of it, then now all of a sudden notice the for each is happy. It says, oh, okay, if you want to, I now know how to go through all of those things in the registration beast. So let's just run it and see what's produced. So there's contestants by largest fish, and notice that I'm getting all of the contestants out, all three of them, but they're not arranged from largest to smallest. Okay, but at least we got them all out for a start. So back to the Derby class, how do you get them arranged from largest to smallest? There's two ways you could do it. One way is every time after you add a fish, you could sort the fish list. Assuming that, all buckets. And that would keep them in order all the time. What order would they be coming out in? So ascending order, so smallest to largest, because that's the default. So afterwards, you'd have to, if you wanted to keep them in the right shape, you'd have to reverse all buckets. Okay, so we can give that a try. And now when we run the thing, oops. Let's just see what happened here. Add fish in the Derby class called collections.sort. Collections.sort did a whole whack of stuff to get down to trying to do the sort. You can see it calling the compare to for buckets, which called collections.max to try to get the next thing out of the list. And when it tried collections.max, used an iterator, which is what that ITR thing is, to try to get the next thing out of the list, and it discovered that there weren't any. Or, to put it another way, you can't call collections.max on an empty list. Okay, so because what's happening here is that we're adding the fish in initially, right? The lists start out as empty, and then if you try to run a collections.max on an empty list to try to figure out where things fit in, how do I fit the thing in an empty list, it's dying. So you can only sort or find work on a list that has something in it. So that's not gonna work for us, is the bottom line, just the way it's coded. Okay? So back to Derby for a second. Good idea, but not necessarily the best way to do it. One of the other problems with that is that it's not exactly the lazy way, because this is this idea that every time you get something new, you're automatically trying to say, oh, where does it fit? I need to keep things pretty. Okay? The other alternative is to wait until somebody asks when they want to go look, and then when they want to go look, it's like, okay, now I'll make things pretty. So if we take the same code and instead move it down inside here, then we're saying when somebody comes looking to go through all of them with a for each, just before we give them the information they want back, we'll make sure that we make things pretty by putting things in order then. And so it's delaying the making pretty until somebody actually comes and asks. Okay? The assurance here is that you're more likely to have something on the list. Okay? And if anything, we should take care of the situation where we might have to put an if statement in here that says if there's nothing on the list, then we can return something that says it's empty and not bother to try to sort. So there might be a special case that we have to put in there, but for now our test data in the driver just makes sure that everybody has at least one fish. Okay? So we'll run that now. And now all of a sudden there's the fish popping out in order. Okay? And so people can run down the list and see all of the fish that were caught, all of the biggest fish by each fisher person to see where they stacked up. So that's actually, if we were to print out a number beside them, that would be first place, second place, third place, all the way down for whatever fish they caught. Anything else we should do? One last thing we said. If we've got a few hundred fisher people in the list, then it's going to become unmanageable for people to try to scan the list to find out where they placed. So it would be nice if we could also produce a list of people in alphabetical order instead of by order of fish weight. How are we going to do that? Could have another way of going through this thing so we can make another iterator, but what's the problem with sorting? Yeah, you know, the thing you want to do is you want to do exactly what you said. You want to go into the bucket class, which I just made go away, and say, well, that's fine. What we'll do is we'll get the buckets to come out in order of by people, by first name and last name instead. The only problem with doing that is that bucket already has a compare to. You're only allowed one compare to for bucket, and the one that's there does the regular thing, the most expected thing, which is sorted by fish weight. So you can't make another compare to, so this is where we get into trouble of going, okay, now we have to provide some other way of sorting things other than by the default. Okay? So this is the time to make one of those weird comparator objects. Okay? So we'll go into which class should get the comparator object? Bucket, because that's the thing that you want sorted differently. So we'll write public comparator only for buckets, and I'm going to write this in the weird inner class way. We'll do this by last name, first name, actually going to be a method, and that method is going to return a new comparator only by buckets, and the comparator, keep having to remember my weird syntax, is going to end with a semicolon there just to get it right. Make sure we do the import for comparator, and comparators need a method inside them that just compares two buckets. So I'm just going to call them bucket A and B. So how do we write it for first name and last name? How would you do it if I gave you two buckets that had different first names and last names on it? What would you check? Where would you start? Names of two different people start with their last name, so we'll compare their last names first. So we'll take the difference of their last names. So there's the difference. Okay, so I got the difference. What would you say in English? Got their first names and last names. If they're already different or they're not equal, then we're done right away. Okay, so if they're already different, then we can just send back that difference. Otherwise, play the same game all over again with their first names. And in this case, since that's all that's left, we can just return the difference at that point. Okay, so there's the comparator that's going to do the work. Now, how do you actually end up using it? So now we could do something like make another iterator. There's two ways that you could get stuff out of this class. You can either get it out with an iterator, or you could write the get and size methods, and you could allow people to retrieve things by position, 0, 1, 2, 3. We'll use the iterator. So we're going to have an iterator for buckets. And make sure we do the import statement. Same sort of deal here. Eventually, we're going to send back allfish dot iterator. Just like we did before, or sorry, I think I did that in the wrong class, dude. And always doing that? Oh yeah, this thing belongs in the Derby class. It's the Derby that needs the iterator. So we'll go in here, we'll stick in the Derby because that's now all buckets. Dot iterator. Okay, so that'll give us back the all buckets, but we need to sort it first. So we'll do collections dot sort. Sort of looks like the other one. We still want to sort all of the buckets. But now when we sort the buckets, we want to do it by first name and last name. So this is the point where you use, put the word static on the front of this thing, so that that allows us inside the Derby class to say I want to sort by bucket dot by first name, last name instead. Okay, so there's the extra parameter on sort that says don't use compare to for doing the sorting. Use this guy to help you do the sorting instead. Okay, and that guy knows how to sort Fisher people by last name and then first name. Which now leaves us with going back to the driver class and deciding how we're going to use it. So let's go here really quickly and do another print statement and say contestants by last name. How about a for each? Well, can we just do a for each? No. Can't do a for each because this is really already using that iterator, the default iterator, and for each only works with the default iterator. So in this case, we have to use the longer syntax, iterator for bucket, actually use an iterator. And we'll talk to the registration class and we'll say, whatever I called it, go get me one of those iterators by first and last name, and then while iter dot has next, do a bucket. I'll use the same syntax. Go ask it for one. And then since I used the same words in there, I should just be able to steal this, plop it in there, and save it. And we'll just do a quick run of this thing and hope that I got it in the right way. Oh look, contestants by last name. Notice that it's Flintstones followed by Rubbles. And if you don't believe me that it works, we'll just move Fred Flintstone, register them afterwards so that they're now in a different order, and run it again. And it's still got them in sorted alphabetical order. There's another level to that thing. So we got fish, buckets, and fishermen, right? So we're now 3 levels deep. That 3 levels deep scenario like this appears over and over and over again when you write code, right? If you have hockey teams, right? You've got a hockey player that forms into a team and a bunch of teams form into a league and it pretty much stops there, right? So all of those, so there's lots and lots and lots of scenarios in real life that have got that little 3-level structure in them. And so once you've seen this pattern, you can basically duplicate the pattern for a whole lot of other pieces of code that look pretty much the same idea. Okay, so save this one because it's a pretty handy piece of code. And with that, we're out of here.